This video is meant to act as an introduction to sine, cosine, and tangent. Okay, so we have a right triangle. We can label it our longest side across from the right angle is going to be the hypotenuse, and the two other sides are going to be called our legs. And we can also have some angles, and it's probably easier for us to have some letters take place or in the place of the words. And we've got some angles in our triangle as well here. So what we're going to look at are things in this video called sine, cosine, and tangent, and these names come from the first three letters of the sine, cosine, and tangent. So sine, cos, and tan. Now, sine of any angle is equal to the opposite side of that angle divided by the hypotenuse. So what you might see up in the video right here, we've got our angle alpha, and straight across from the angle alpha is going to be our letter A. That's why we're putting A on the top. And then everybody knows that the hypotenuse is our longest side across from our right angle. So if we're talking about cos, what we're doing is we're talking about our adjacent angle divided by our hypotenuse. You can see there our adjacent is in red, and so that would be the letter B, and our hypotenuse is still the letter C. And lastly, we've got our tangent, which is going to be equal to our opposite over our adjacent, which we've already labeled as A and B. Okay, so we have a right triangle here, and this time we're going to look at the angle beta, which is in the bottom right corner. Now, there's going to be an important phrase here, SOACAHTOA. I know that looks like a bunch of nonsense, but we can actually simplify that down into three sort of parts, where sine is equal to our opposite divided by our hypotenuse. So right there you can see the sine of beta is equal to our opposite side, which is the letter B, divided by our hypotenuse, which is the letter C. So we can go ahead and solve some problems when we know some numbers. Now there's a second function we can use, cosine, which is in red. So cosine is equal to our adjacent angle divided by our hypotenuse. So the angle that's adjacent to beta in this example is the letter A. You can see that pointing to in red, and our hypotenuse is still C. Our final one to work with here is tangent, which is going to be our opposite side divided by our adjacent side. And so in this example here, we've got, and we've already labeled this, the angle that's opposite beta right now is the letter B, and the angle adjacent to beta is the letter A. Okay, so let's go ahead and take a look at an example on this slide here, and it's probably easier to use some numbers instead of the letters that we've been using so far. Probably the easiest numbers to use are going to be 3, 4, and 5. So instead of A, B, and C, we're going to have 3, 4, and 5. So first thing we're going to do is we're going to look at the sine of our angle alpha. Now we do have to remember that we're doing sine, we're looking at the opposite and the hypotenuse. So what number is opposite our angle here? Well, it's going to be the number 3. And what number is representing the hypotenuse right now? That's going to be the number 5. So all we're going to be doing here in this example is taking the number 3 and dividing by 5. And that's going to be your answer for sine. If we want to look at the tangent one next, now and again, recognize here that we're talking about the tangent of angle beta here. So what number is opposite of beta? Well, that's going to be the number 4. And what number is going to be adjacent or beside beta? And that's going to be 3. So in this example, we've got 4 divided by 3. Here's a quick review. Let it all sink in. Thank you for watching.